I'd like to go over how you might use Excel and SPSS on a day-to-day basis for statistical calculations. Okay, so I posted onto the Blackboard sites a tab on the left-hand column, on that button column on the left, an extra button called Data. And if you go into that button, you'll see a pair of files for this particular exercise. Okay, so if you'd like to run them at the same time that I do, you can watch what I'm doing in one window, and you can be working with Excel in another window. Okay, good. So thank you for that. Yeah, thank you, Marcus and Tari. I appreciate that. Okay, so I'm going to open up this Excel file. Again, it's a series of heights. We'll examine it just to see what we're dealing with there. And as I said, you can get this in that under that Data tab. Okay, here we go. My version of Excel is just a little bit sluggish. Okay, I'm going to blow this up a bit so you can see it a little bit better on your screens. In fact, maybe I can even go a little bit bigger than this. I think we're a little bit out of the range I wanted it to be. How about 160? Good, I think we're going to work there. That looks pretty good to me. All right, so what we have here is we have a bunch of data for starting in row 2 for how many people we have here. Let's go all the way down here. It's a pretty big data set. It's got 381. Remember that first line was a header. Line 1 was a header. So we actually have 381 individual subjects, patients, experimental data. We have 381 samples. In this case, it's people. And we have in column A, we have the variable height, their height in inches. And in column B, we have the variable gender, which is, in this case, is just indicated as male and female. Okay, so what kind of variable is height, for instance? Okay, someone want to type into the chat box, tell me what kind of variable height is. It's numerical, right? If we're working with SPSS, it calls it scalar, but it's a numerical variable, right? It's a continuous scale. You could have almost any value, right? You could have 69.5 inches, 69.25, 69.01, and so on. So it's a continuous scale. Okay, and what about gender? What kind of variable is that?
Gender is categorical.
Right, categorical variable. Categorical and nominal, we could use either name for those. It's a categorical nominal variable, but it's a special kind, right? Because how many values is it? It's dichotomous. It has 2 values, so it's binomial or dichotomous, right? Right, dichotomous. Thank you very much, Marcus. Okay, good. So it's kind of a special version of a nominal variable. So we're going to look at this first variable, height. Okay, and when we look at this, if I scan through these numbers, it's very hard to interpret, given how many variables there are there. What was that? How many variables there are there? We had this very loud noise in here. It came from nowhere. We have so many values here. Oh, in fact, look at that. We have one that's a missing value. I'm just going to block that out so I know about that. We have a lot of values here, and it's very hard to interpret this. To interpret what the average of, what the middle it is, the median value, how spread out this is, by looking at all of these numbers in a sequence like this. Okay, so we want to be able to summarize what we know about this sample in an organized manner. We want to have an idea of where the middle is, and we have various statistics that we can use to determine the middle. That might be mean, median, and mode. We have other statistics that we can use to describe how spread out these values are. Minimum, maximum, range, percentile, variance, standard deviation. Hold on, guys.
I'm sorry to interrupt. Is this a class?
It's actually, I'm broadcasting an exercise, but they didn't have a class scheduled in here. Do you have a class in here?
I have a class at 6. I want to be able to.
Are you in which class are you in?
Public health management.
Oh, okay, we'll be out of here by 6.
Oh, actually, before. Okay.
Oh, I'll be out of here by 5:30.
Perfect, thank you.
No problem. Okay, sorry, guys. So at any rate, so we have various ways of describing the spread, how spread out these values are, and how and where the middle of this is. And that's what we're interested in when we're working with numerical variables. When we look at gender, nominal or categorical variables, we're going to be looking at that data in a different way. Okay, so let's take a look at these numbers. Okay, so first thing I might be interested in is the mean. Now, what I've done here is I've summarized the most common variables, statistics that you might be interested in for numerical variables, and I've put on the left right-hand side, I've put the description of how you would find that variable using the functions in Excel. Okay, now the reason why I'm able to type it in that way is because I stuck a space in front of that equal sign. So you're not going to be able to just copy and paste this into another cell because you need to get rid of that space in order for it to work like a variable like that. See, I just took that space away and it actually saw it as a variable then. Okay, so, but this will give you an idea of a reminder of what these various functions are in Excel. Okay, so for mean, we don't actually have a function, excuse me, we don't actually have a function called mean in Excel, right? So we use the arithmetic average, an arithmetic function called average, equals average, parentheses, and as soon as I put parentheses in, you'll notice that it prompts me on what information it wants to know. It wants to know what range of numbers we want to know that we want to take an average of. So I could tell it that we want to take an average of the values from A2 and then colon, and then the last value that we're interested in is A382. A382. And Excel will calculate that average for me. Oops, didn't like something there. A382. And I think maybe there might be another missing value there. I'm putting I am clicking on that. Whoops, I need to escape here. I'm gonna make sure that's just a blank value because it found a word in there, didn't know what to do with it. Okay, I'm not putting a 0 in there because we don't know the value, right? It's not 0, it's just an unknown value. So I'm gonna leave it a blank. Excel and SPSS will tolerate blank values, missing values. It'll handle them correctly. In fact, you can give it some more details on it if you have a special way you want to handle missing data. Okay, so I'm thinking it worked, but there you go. It automatically straightened that out and it worked in this case. And if you want to see what the formula is in any particular cell that you've already worked on, you could just go up here and click into that cell and it'll appear in that little window at the top. Okay, so I'm gonna go ahead and continue with this. The median is going to be equal to the value the statistic median, parentheses, and again, as soon as I get to the point where I put that left bracket in, it's asking me for what I would want to do with these, what range of values that I would want to do this for. And again, I could put in A2, maybe you can turn the A2 through A382. And enter, and the median value, the middle value, is 67. Okay. You should be seeing what I'm typing here. The video image isn't changing. That's very interesting. Is that true for all of you guys that the video image isn't changing?
Yes.
Goodness. Okay, I tell you what, let me turn off screen sharing and turn it back on again. Okay, how's that now? Can you see things changing here now?
Yes.
Yes, that's a yes. All right,
Yes.
I'm going to step back again. I'm not tired or bored. I'll keep doing this until it works.
Thank you.
Okay, so let me start again. In this file, we have 381 values for individual subjects' heights and their gender. The height is a numerical or scalar variable. The gender is a nominal or categorical variable. In this case, it happens to be dichotomous. It has two values, male or female. Okay, so when we deal with numerical variables, we're interested in where the center is. In other words, the mean, the median, the mode, those particular statistics. We're also interested in describing how spread out it is, or understanding how spread out it is. And for that, we have a number of other kinds of variables: maximum, minimum, range, the percentiles, the interquartile range, for instance. I'm going to add that one in there. Interquartile range. I'll add that one in there. And variance and standard deviation. Now, variance and standard deviation are going to be particularly important to us as the semester goes on, but we'll talk about that later. I've also, as I said before, I want to repeat this so I make sure that everybody has gotten this. I've summarized here what these functions are in Excel that will give you these particular values: mean, median, mode, range, so on and so forth. And I put an extra space in here, so Excel allowed me to display them. But you can use that kind of as a reference. Put the equal sign, average, and then the data that you need to find the range, the average of. Okay, so again, mean, that is not a specific function for mean, but there is one that says average. So I'm going to type in the equal sign, let Excel know I'm going to put in a calculation or a function, and I'm going to type in average. And you'll notice that as I type it in, it's telling me what functions are available that start with those letters. And average is enough for me. And as soon as I hit the left parentheses, the opening parentheses, it tells me then that it wants to know within the parentheses the numbers that it wants me to average. So in this case, I know that the numbers I want to average are in the cells between A2 colon and A382. And I'm going to hit enter. Okay, and there's my mean. Now next, I also want to know another measure of the middle of this distribution of individual sampled subjects. Okay, and that's going to be median, the middle value. In the case of 382, it would be 150 plus 40 is 390, the 391st person if I had them sorted in a row. Okay, so in here, I'm going to find out the median is equal to median, parentheses, and again, it wants those same numbers, A2 through A382, close parentheses, and the median is 67. Now, the mode is the most frequently occurring value. Which value occurs most frequently among these heights? So I'm going to say equals mode, parentheses, and let's see, A, and you may notice that it really doesn't care if it's upper or lower case, A2 colon to A382, that string of cells. Okay, and the mode is 64. Now let me ask you something. The mode is the most frequently occurring value. You know, I'm looking at this data and I'm thinking this data might have two modes. Anybody have any idea why I might be thinking that perhaps there are two values that occur very frequently in this data set? Why would there be two modes in here instead of just one mode? Well, that could be, but what kind of people are in here? What do we know about this group of people? Is it all males?
The same male and
No, it looks like it's all male, but there's females for down further, right? Okay. Exactly. We have two groups there, so it's not really a single kind of population, is it really? So yeah, so really, I'm suspicious that there might be one mode for females and another mode for males. I might actually see kind of a double hump camel kind of thing, right? Where I have a distribution where there's one hump where is the middle of the female heights and another hump where the middle of the male heights is, right? So kind of interesting, right? So okay, so let's take a look at it let's take a look at a way to describe the spread of this sample. Okay, so one simple way to do it is to look at what the minimum and the maximum is. And there are functions for minimum and maximum. Equal, max, parentheses. And just so you can see it, if I don't remember what these numbers are, I can click down and drag all the way down to 382. And again, it's going to tolerate these missing values. It'll ignore them. 382, go a little faster. Okay, you can see why I'm typing it in instead of like doing this all the time. Okay, 382, and I'm going to close the parentheses. You can see it up there, and hit enter. And let's see what I wind up with. It's 91. It's my maximum height in this sample. Okay, what's my minimum height? It filled those letters and numbers in for me. My minimum height for A2 through A382 is 56 inches. So what is our range? Well, our range is our maximum height minus our minimum height. So the spread for this sample is 91 minus 56. So there is a range of 35 inches between the shortest person and the tallest person. So we have a little bit more idea of where the middle of this distribution is and and how spread out it is. Okay, now we can even go beyond that and look at the percentiles. For instance, 75% of the people are less than this particular height, the 75th percentile. And how we calculate that? Well, there's a function called percentile equals percentile. There's a lot of different, you'll find in some cases, there are different versions of the same statistical function. For the most part, where we're concerned, you can just simply use percentile or average and so on and so forth. You don't have to worry about the alternatives that might have special applications. So percentile, for the array, the list of numbers, notice it's interested in an array and some value called k. Okay, well, that value k is the percentile, 0.75 for 75th percentile, uses the decimal instead of percent. Okay, so the array is A2 through let's see what we are, 382, and hit enter. Whoops, I forgot to put in the percentile, comma, 0.75. And 70 is the 75th percentile. In other words, 70% of the people are less than 70 inches tall. 25% of the people are greater than 70 inches tall. How about the 50th percentile? The 50th percentile is going to be equal to percentile, open parentheses, A2 through A382. And let's see, 50th percentile is going to be 0.50. Okay, and you know, before I hit enter, anybody have an inkling what the answer might be here? What is the 50th percentile? Half the people are below this, half the people are above this. It's the median, right? Should be the same as the median. And in fact, there it is. It's exactly the same as the median. So the 50th percentile is indeed the median. Okay, so let's go to the 25th percentile. Equal percentile. And the array to A2 through A382, comma, 0.25, and hit enter. Okay, now that's 25% of the population is shorter than 64 inches tall. The interquartile range is the range, kind of the range was minimum to maximum. The interquartile range is the middle two quartiles. In other words, everything from the 25th to the 50th and from the 50th to 75th. So in other words, it's equal to the 75th percentile minus the 25th percentile. Whoops, didn't quite work there. The 75th percentile minus the 25th percentile. The interquartile range is 6. 50% of this population is within 6 inches of each other. Okay, so many of the people are within the same range of height. Fewer and fewer people are extremely tall or extremely short. So that's kind of interesting way to look at the middle of the Yeah, 25th percentile being the mode is a coincidence. Although, to be honest with you, when we look at it later on in SPSS, maybe that's because the 25th percentile happens to be about where the average height for females is, right? So we'll take a look at that when we get a chance. Okay, so now another important measure of spread is the variance and the standard deviation. We went through a very elaborate discussion of how to calculate that when we were working with the example that we used in class earlier this week, or online for the online people in the online class. So I'm going to go in here, and I'm not actually going to go through that complicated derivation of the variance. You can go back and take a look at that. I'm just going to use a function that's already built in. I see there's a couple of questions here. I'll make sure I answer them. VAR. And the variance is got for A2 through A382. And I'm going to hit enter, and the variance is equal to 16.84. And the standard deviation is going to be the STDEV, parentheses, and A2 through A382, close parentheses. And the standard deviation is 4.1. Can somebody tell me something interesting about the relationship between the number, which is the variance, and the number, which is the standard deviation? Is the square, right? The standard deviation is the square root of the variance. Exactly right. Thank you. Can you write what the interquartile range function is again? It's not displayed. Okay, yes, I can do that. It's equal to, whoops, didn't want to do that. It's equal to the 75th percentile minus the 25th percentile. Okie doke. Okay, it's not actually a function in Excel, but we can calculate it by finding the difference between those two percentiles. Okay, so we've done quite a bit here. We've calculated using just Excel, not a specialized piece of software, but just Excel. We've calculated a lot of important statistical functions that are specific to numerical variables that help us understand where the middle of a distribution is and how spread out a distribution is. Now I'm going to take a look at the next column, and the next column is a nominal variable, right? And the nominal variable is going to be handled quite differently, right? Because, for instance, male and female, right? That's not something that we can add up and average, right? Would not make any sense to get an average of that, right? So instead, we're going to be producing what we do for most categorical variables or nominal variables. We're going to produce a frequency table. Now, there is a way that couple of ways that we can do this. This data happens to be sorted. Did you notice that all the females are down there and all the males are up at the top? That's just by coincidence. There is a function in Excel called count. I'm just going to put it in here, count equals count, right? And parentheses, where you can highlight a bunch of cells and tell it to count how many items are in those cells that are not empty. Okay, male, and count if, and that should be B2 through B382.
You said
and it worked that time, of course. Okay, so now I noticed 381 people in here. I could just simply say equals 381 minus 119, but instead of that, I'm going to use the count function again. Count, and then I'll take a break and I'll take a look, see if there's any questions. Count if, parentheses, again, it wants the range, which is A2 colon, oh my goodness, B2 colon B382, comma, and this time the criteria that's going to be acceptable is the word female. And close quotation and close. Okay, and that's 282. And you'll notice that this adds up to our 381 people, so it works correctly. Okay, so let me take a look at, there's any questions there? Okay, none on this anyway. Okay, I'm sorry I stumbled on that, but when you're live, this kind of stuff happens occasionally. So You guys have any questions about this so far? About the idea of why I'm making a frequency table up for male and female and how I did it, and why I use these particular statistics when I'm working with numerical variables. Are we okay with that? Are we awake out there? Okay, good. I'm glad to hear that. Good. Excellent. All right. Yeah, I can't tell, what's going on out there. I don't know if you're relaxing with a cocktail, if you're, watching TV while you're doing this. So I'm in the dark here. You can tell what's going on here. I can't tell what's going on there. So occasionally I need a little bit of feedback. Okay. So one other thing I wanted to mention to you is that with these frequency tables in Excel, I can actually display this fairly easily. Okay. I'm going to click on this cell. I'm going to click into this cell and this whole frequency table. And I'm going to go up to at the top. Now, different versions of Excel look a little bit different. So in my particular case, there's a ribbon here where I can click on charts, or you can go up to the top and select in tools or somewhere else. You can select insert chart, for instance, somewhere in here. But I can just simply click on this ribbon called charts, and it gives me a lot of options for the kind of charts I want to create. In this case, with categorical data, we're typically creating something like a bar chart, a column chart, a pie chart, for instance. So let's create a column chart. So I'm going to click on column, then I'll click on clustered column, which means that they're together, and there we go. Almost instantaneously now, look how easy it is for me to see what the relative population of this sample is, what the relative distribution of the sample is with regard to male versus female. It's very obvious. I don't particularly need this legend over here, so I'm going to just delete it and get rid of it. Maybe I don't like these lines. I think I can get rid of them also. If I click on them, yeah, I think I can get rid of those also. Not only that, I can click on these bars, control, click and format on these bars, and I can say, I'm sorry. And let's see, add data labels. And look, it actually added in for me what the quantity is for each of these different bars. Okay, so I can do a lot of work in Excel, graphically and numerically and with statistical functions. Okay, so we're gonna leave that now. We're gonna take a look at SPSS, and we're gonna work with the same data set in SPSS. If you look on that data folder in the on Blackboard, you'll have the heights, the height file as heights SPSS.sav. .sav is SPSS files. Okay, and there it is. So I can start it two ways. I can double click here, or I can go down here and I can tell it to start SPSS for me and then open that file from SPSS. How many of you guys have already downloaded and installed SPSS? Okay. Those of you that are School of Public Health students have access to a free download for SPSS. You have to download the program. You've seen the instructions around Blackboard. There's a document that'll step you through it. You have to download the program, which is a zip file, open it and install it on your computer. And then there's a second file, which is a license file, which has a license number in it. You install it as an individual file on individual program. And then when it comes up, starts up the first time, or as part of the installation process, it'll ask you for that license number. You put that in and it'll give you a license to operate that on your computer for approximately 12 months. I think until August 1st of 2019. Just between me and you, just so you know, it'll let you continue to use it for a month after the expiration date, and we just keep reminding you that it's about to expire or it has expired. But it'll give you a leeway of a month in case you need that little extra bit of time. Okay. All right. So Fernando can't hear me. Can you guys still hear me? Are we still okay in terms of seeing and hearing? Okay, good. Must be sometimes one or two of you may have perhaps an internet speed issue or a glitch or something like that, and I may temporarily go out or in. Hopefully you'll be able to later on go look at the recording if there's any part of this that you've missed. Okay, so here we go. I have SPSS open in the background here. It opens up with this kind of template window where I can navigate, start a new data set, and so on and so forth. You can click this and tell it not to show this anymore, or you can just close it and get it out of the way. I like to just close it. Now, I can't close this blank file. If I close this blank window, it will shut the program down. So in order to open a new file, I have to leave that as it is. Go to File, Open, Data. If I'm going to start a new data set, I just say New Data, and it'll give me a blank window like that. Open, Data will allow me to open an existing file. And then I would navigate to the location where I have the file. In my case, I happen to have the file in my user area on my desktop in a folder called Session 1, I believe. And sure enough, there is that file, height SPSS.sav. Notice you can't see the Excel version of this file here. That's because when you open a file in SPSS, it defaults to looking for only SPSS files, right? Not SAV, compacted files. Okay, if I wanted to see Excel files, I would have to click here. So now you can see the Excel version of that file. I could even go down if I wanted to, go all the way down here and tell it to show me all the files that are here so you'll see both. Okay, so in our case, we want to open this SPSS version of this file. Okay, take a moment to open up. Now, what happens first is an output window opens up. You may have glanced at that very briefly. Notice there's a second window open behind this file. That's this file window. That second window is an output file. It describes the syntax or the language that SPSS speaks in. It describes what we've just done, which is to open this file that is a data set named height_SPSS. Okay, so that output window is going to hide back there for a little bit. Okay, but it's going to come back again in a little bit. Now, the data window, remember we have two windows here. We have the data window and we have the output window. The data window has opened up. It happens that it opened up in one of two views that it has. One view is the variable view. The other view, if I click down here, is the data view. And I can switch back and forth between these two views. In fact, if I go up here, I can go in here and tell it to click back and forth, variable view, data view. That's a toggle. When you hit it and it goes to the other one, and you hit it again, it goes to the other one. That's toggle, like almost like a toggle switch. But you can do that down here as well. Okay, so you may notice that instead of seeing male and female here, you see for gender 0 and 1, right? And you'll see that throughout here. You see all the numbers represented here, but you see 0 and 1 for the actual data, for the gender data. Okay, that's because in SPSS very frequently we will enter the data as a number representing a value for a categorical variable because it's easier than typing a word. For instance, if these were boroughs, I could name each borough with like 1 for Manhattan, 2 for Brooklyn, 3 for Queens. Instead of typing Manhattan, 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 I could just simply type 1, 1, 1, and for Brooklyn, 2, 2, 2. It's more accurate and it's easier and more efficient to do it that way. So in this case, we've entered 0s and 1s for male and female. Now, in order to tell SPSS what that 1 or 0 represents, we go to the variable view. And notice we have two columns here. One represents the variable height. In SPSS, just like we saw it in Excel, the variable is in the columns, and the subjects or the records are in the rows. Okay, so we have 381 rows here, just as we had before. Let's go here, the 381. See, the first row actually has data in it. There we go, 381. In this case, first row has data, and the variable names are up here, not as part of the document. Okay, so the numbers are clear. We understand those. But gender, we have to describe to SPSS what those numbers mean, so that when it creates a table for us or a graph, you won't see 1 or 0 describing what's in the graph. You'll actually see male and female. So it makes sense to people that might be reading that document. And yes, you can import a data set from Excel into SPSS. I'll show you guys how to do that the next time we work. I'm not going to cover that right now, but I'll show you guys how to do that the next time we're working with SPSS. So what I'm going to do now is going to go into the variable view, because I want to make sure that this is set up correctly. Okay, so here is my variable. For every column, we're going to have a row in the variable view that represents that column. So the name is called height. Okay, so that's pretty straightforward. That's the variable name. Variable names always start with a letter. They can't have any spaces or special characters. They can have letters and numbers, and they can be pretty long, but usually you wind up with a kind of an abbreviated name like height and gender. And you might want on your tables and graphs, you might want a better description of what that variable is when you produce those tables. So what you can do is you can put into this label column the description that you want to substitute for just height when it produces a table. So we wanted to say height of student, or we might want it to say gender of student when it produces a graph. Now I've already put this in for you, but later on, when you're working with your own data sets, you can actually decide for yourself what you might want. Okay, maybe I'll change this just to S so that you can see that there is that like I can actually influence that here. Okay, and as far as the type of data, it says numeric for both, right? Because that's the way it was input, numbers, and for male and female numbers as well. The real thing that identifies what kind of variable it is down here by measure. Okay, so let's keep going across. Okay, so for the first row, in the height of students, values, we don't have to worry about that because the numbers are already, they're just numbers. They have their own values. Don't worry about missing values, just ignore them. How many columns do you want to display? We have 11, we don't need that many, it's okay. How do you want to align the data? Okay, it happens to be right aligned or left aligned, or you can center it. This one's important though, measure. Measure tells us what kind of variable it is. And we know that height is a scalar or numerical variable. So we're going to leave that just the way it is, right? Scalar. Notice it has a little ruler there to indicate what kind of variable it is. Let's look at the second row. Second row is gender. And let's go over here to make sure it's the right kind of variable. Oh, it says it's nominal. It identified as nominal. And in fact, it is a nominal variable. That's what we wanted to recognize that that variable is. So this is correct, right? We have it right. It's not scalar and it's not ordinal. It's nominal. Okay, but with nominal variables, often we're going to want to know what those numbers, if they're displayed as numbers, or if they're entered as numbers, we want SPSS to know what those numbers mean. So that the place where we do this is under values. Under values from numerical variables, we don't put anything in because the value is self-descriptive. It's just the number. Okay, but for values under nominal variables, we need to tell it what 0 represents and what 1 represents. So I'm going to click in here, and if I click in there, I'll click that again. If I click in there, you'll notice a little gray bar, a little gray box opens here. I'll click in there, and a input window comes up, and and you can see that it already understands, or I've already described to it, that 0 represents male, 1 represents female. Okay, if we wanted to, if there was room in here for this or other values, I could put other. Or excuse me, I could put the value 3 represents other, and I can click and add it to this, right? Since there aren't any others except a male and female in this particular data set, I'm not going to bother to do that. Click OK, and then go ahead on with what I'm doing. So I'm going to go back to the data view. Now, just to confirm that that's actually happened, I can go up here to View, and I can tell it to show me those values here instead of the numbers. So I'll click on that, and notice how that changes to male and female. I'll go up here again to View, and I'll click on Value again. Notice how it goes back. So I can toggle back and forth between turning on the value labels and turning off the value labels. Okay, I'm going to leave them turned on. Okay, so now let's see what we need to do the statistics that we just were discussing in Excel.
In SPSS, always need to remote, variable.
Well, you need to make sure that the variable view has the variable described correctly, right? But it's always there. It's always there in the background. You know, once it's set up, you don't have to worry about it again. Okay, what do you need to do first? Well, you know, you could do either. You can input the data. You can set up the variable first and then input the data, or you could input the data and then go back and clean up the variable view. Really doesn't matter that much. We need to access the table under the variable view. When we do a graph, now, no, remember, all we're doing now is describing the data to SPSS. We're not actually making a graph or a chart or doing any tables or calculations yet. We're about to do that right now. So now once our data set is set up, the variables are correctly described, we can go ahead and do our analysis. So I'm going to start with the numerical variables just as I started in Excel. And the way I work with this is, unlike Excel, which these other cells can contain formulas and calculations, the only thing that these cells contain in SPSS is data, words or numbers. Okay, if we want to do an analysis, we go up to the top here where we have the access to all these different functions, okay, in these drop menus. I'm going to click on Analyze. Seems straightforward enough, right? And then since I'm doing descriptive statistics, mean, median, so on and so forth, I'm going to click into descriptives. Now, frequencies, you know, frequency table is what we do with a nominal variable, right? With male and female. Okay, so I'm not going to use that for our numbers. I'm going to go to descriptive statistics. I'm going to click on that. Okay, and it comes up here. The next thing it wants to know is that it wants to know, well, which variable do you want to work with? Okay, well, we're working with the height of the students right now for descriptive statistics. Okay, so there are options here, style. I'm just going to click into options. And in the options, it asks me what descriptive statistics you want to calculate. It's already highlighted mean, standard deviation, minimum, maximum. I'm going to click on variance, range. That's, I think for now, that's about all I'm interested in. Click continue, click OK. What happens now? Well, the output window pops up. All of our final answers, all of our calculations go into that output window. When you save these windows, you have to save the data window and the output window separately, or you'll lose whichever one you don't save. There's two separate files. The data file and the output file are two separate files. So here now we have a table which tells us how many valid results we had, 379. Why not 381? Because there were two missing values, remember? Okay, range is 35 to 56. We knew that from before. The range is 35, the difference between the lowest and the highest. The minimum is 56, 91, just the same thing we got before. And look, our mean, standard deviation, our variance, instead of having to type in all of those functions and the ranges of those functions and all the other parameters that it needed, SPSS in a moment, in a flash, gave us all this information. In fact, I can go into Analyze, Descriptive Statistics. I can go past descriptives into this function called Explore. And this time I'm going to move over. There's several other boxes. We're not going to use them right now. I'm going to actually we'll use them in just a little bit. I'm going to move this height of students over into what's called a dependence list. That's the value I want to work with. And I'm going to click on statistics, and there really isn't anything for me to click except to do the descriptive statistics. And I'm going to click into plots, and gee, it'll give me some options here: stem and leaf, histogram. I'm going to click histogram. Maybe we'll get a histogram for this data. I'm going to click continue. I'm going to click display both the data, the descriptive statistics and the plots, not just one or the other. Click OK. And let's see what happens. The output table comes up again. And look, we have all these other statistics, the interquartile range, so on and so forth. We have all this other stuff that SPSS is calculating for us. And look, it's also produced a histogram for us as well. Okay, and look, this guy's an outlier. He must play for the Knicks or something like that, right? It's ridiculously tall. So that guy turned out to be an outlier. Okay, and this is a side plot. It's called a stem and leaf. We'll talk about that in the future. Look at our box plot. Here's our box plot, our shortest height, our tallest height, our median, and our 95 and our interquartile range are in here. You can see that. Notice it's displaying the word, the description height of students rather than just height, because we put that in as the value label that we wanted it to use instead of the variable name. Okay, and notice that this 26th value, notice identified where in the data set does it located. This 26th value was an outlier, right? I kind of knew that was going to be a little bit of an issue. That's why I kind of threw it in here, because I wanted you to see an outlier, what an outlier looked like. SPSS uses kind of funky rule for deciding what's an outlier. You really have to reason whether or not the value is so different that you can exclude it from your data set. You can justify that or not. You can't just rely on SPSS to use its weird rule, which is, I think, 1.5 times the interquartile range above the 75th percentile. Anything more than that is going to be considered an outlier or above the distant from the other values. Okay, so you have to put a little bit more thought into it than just that. But using SPSS default rule, that looks like a value, like a likely outlier. Okay, so we have all sorts of information that we've got here, isn't it? Okay, and some graphics and so on and so forth. Just want to show you one other thing about this. I'm using this program because I have a funky problem with Word and pasting in images and stuff like that. Okay, this is a open source program. Okay, I can go in here and I can click on any one of these tables and I can say copy, and then I can go to my word processor and I can say paste, and I can have it paste that table into my word processing program, into my document. So I can use all these tables and graphs and so on and so forth that SPSS produced. I can use them now in my projects, in my reports, in my homework assignments, and so on and so forth. In fact, the first homework assignment, which you actually, because we have holidays and stuff, you actually have a pretty extended period of time to get around to, so you don't freak out. But one of these things it asks you to do is to create a couple of these and to put them into a Word document and to upload them to as one of your responses to a homework question. My real objective there is to make sure that within the first couple of weeks you get SPSS up and running and Excel running, so I know you have it and you're at least started with it. You've opened it up and you started working with it. Okay, so what about our nominal variable? What are we going to do about our nominal variable? Okay, well that's going to be different. We're not going to do the kinds of descriptive statistics we do with numerical variables. We're going to do counts or frequencies. All right, so I'm going to go up to Analyze, Descriptive Statistics, Frequencies, and this time I'm working with the gender of the students. Notice I can easily identify which is a nominal variable by the symbol that SPSS uses. I'm going to move it in there, and statistics. Let's see. I want well, these really don't apply to that, right? They're numerical. They apply numerical variables. I'm going to say charts. Let's ask it to produce a pie chart this time instead of a bar chart. And our chart values, let's see, we could use frequencies, the actual number of people that are male or female, or the percentages, and have that displayed on our pie chart. I'm going to leave frequencies there, and I'm going to click OK. Again, our output table comes up, produces a frequency table for us. How many males? 119. How many females? 262. What percentage of each? And a pie chart that shows what each was and the legend to go along with it. So we can tell what part of the pie chart is male and what part of the pie chart is female. You can actually double click into these and you can edit them if you want, change fonts, so on and so forth, change the layout, and so on and so on. Okay, so I'm not going to worry about that for now. Okay, so if I had chosen bar plots, it would have produced a column chart or a bar chart instead of this pie chart if I had wanted it. I want to show you one other thing that we can do with this, and that is, this is sneaky. This is not in the first homework, but it'll be in subsequent. We'll definitely be working with it later on. I'm going to go, actually, I think it might be in the first homework, on the data set first homework. I can go up to Analyze. I can go up to, and this is the last thing I want to cover here, I can go up to Analyze, Descriptive Statistics, Explore, not descriptive, but Explore. Explore gives me more options. And I can say, oh, okay, it's still in there. I'm going to analyze I'm going to find numerical statistics for mean, median, variance, and so on for the height of the students, right? But you want to know something? I want to break it up into male and female, right? Rather than look at all of the students together, let's break it up into male and female and compare male and female heights. Okay, how might I do that? Well, let's think about this. When I break things up mathematically, it's called factoring, right? For instance, 20 could be factored into 4 times 5, right? So I'm breaking it up. Okay, so I'm going to say, let's factor this by the gender of the students. Let's break up this data into 2 groups, male and female. So I'm going to put gender into that factor list. Okay, and I'm going to ask it to do the plot. The plots are already in there. I'm going to ask it to do all of those. And I'm going to click OK. Let's see what happens this time when our output table comes up. When our output table comes up now, whoops, I made it go away. Let me bring it back. When our output table comes up, right, now we have 2 complete sets of descriptive statistics. One for males, average height 71 inches, and one for females, average height 66 inches. For instance, I can compare the variability and the middle, the medians, the middle or averages or medians of the 2 groups. Okay, and then I also have a histogram produced separately for males. Notice gender equals male, or for females. And not only that, it produces box plots. So I can visually see in these side-by-side box plots that males are considerably taller on average than females are. And I can see what the range of values is like for males and females, right? And I can see that, see these outliers, how many outliers there are, how skewed the data is, and so on and so forth. Okay, so I get a lot of information from these side-by-side box plots. Okay, so I think that that's a decent introduction for a first week into Excel and SPSS. I think if you can do this or feedback this to me for the first assignment, which will be posted, right? And we have a couple of holidays coming up and stuff like that. It'll probably be due the end of not the end of next week or even into the following week, probably be due then. So you have a little bit of time to get SPSS installed on your machine and working, and Excel, access to Excel. So you got a bit of time to worry about this. But if you can accomplish this, and that'll be part of the first homework, if you can accomplish doing these and then pasting it into a document and uploading it to in answer to the questions in the test, then I think we're getting we'll have a pretty good start into all this stuff. Do we need to use? No, R is completely optional. R is an open source statistical program that is a little bit more demanding in terms of doesn't have as sophisticated a user interface as SPSS does. So you have to do a little bit more work in understanding how to program it. But there are overlays that'll help you with that, like programs, side programs are that'll help you with that. But you can use R if you want to be adventurous and you're a little bit of a program geek. You want to use R. You're perfectly willing to use R to produce the output that you're going to upload for the assignments or for the test. But it's not required. And it's not technically, it's not supported. So in other words, it's going to have to support yourself in figuring out how to do stuff. Okay, now it may be Levi and I will probably post a few videos here and there that might help you out with that stuff. But for the time being, we'll definitely be using SPSS. You'll be required to know how to use SPSS. It's okay for you to use R if you want for the homeworks and for the exam. If you feel comfortable with it. Okay, guys, so I think that's a good start. And for some of you guys that are doing strictly online, this is the first time that you've actually interacted with me live, right? So I'm sorry I stumbled a little bit in the beginning there, but these things happen when you're live. Okay, so good. So I'll see you either online or in person next week, depending on how you're taking the course. And have a good holiday in the meantime. Enjoy the last real weekend of the summer. Bye, guys.
Okay, thank you.
You too.
Thank you.